we want to take a look at sequence and series. Now, sequence and series talks about a way to arrange numbers. So let's begin with the introduction. Now, arranging numbers can be done in a particular pattern. A pattern of numbers given in a definite order is called sequence. In sequence, when the numbers are arranged, the order in which they are arranged can either be done using a rule or a formula. Now, this means that sequence is a set of numbers written in a definite order in which a rule or a formula is used to obtain the number. So, whilst we are talking about sequence, we are talking about the way of arranging numbers such that that particular order of arrangement will give or is given by a formula or a rule. Now, simply put, a sequence is a way of arranging numbers for which the order of arrangement of the numbers can be known. Each of the numbers in the sequence is referred to as a term. Some examples of sequence are given below. All these are types of sequence or examples of sequence. Now, if you see any of these sequence, it is an arrangement of numbers. Now, the first one, 2, 4, 6, 8, 10, 12, 14. We can see the order in which the numbers are arranged. That means that this sequence has a particular pattern, a particular order, a particular formula in which they come from first term to second term to the third term, or even a particular rule that brought all these numbers to become the sequence. So what we are saying is a way to arrange sequence in a particular order. A way to arrange numbers in a particular order is referred to as a sequence. So the arrangement of numbers in a particular order, either using a pattern, using a formula, or using a rule, is referred to as a sequence. Now, some common sequences have special names. Here are some examples you should know. Number one, counting numbers or natural numbers. Now, counting numbers start from 1 to infinity. So you realize that in the example given, counting numbers such as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and so on. So counting numbers are numbers that can be counted. Okay, so they start from the number 1 to infinity. Also, another type of sequence is even numbers. And even numbers are numbers that are divisible by 2. In the example number 2, you realize we have even numbers such as 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and 22. So these are some of the common sequences. We also have a common sequence referred to as odd numbers. Now, odd numbers are numbers that are not divisible by 2. Unlike even numbers, when you divide odd numbers by 2, you should get a fraction or you should get a decimal number. So in the example 3, we see odd numbers such as 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, and so on. Also, another common type of sequence can be the square of numbers, or popularly referred to as perfect squares. Now, perfect squares are numbers that can be in their square format. It means that those numbers can be converted into a square. So an example can be 1. 1 can be converted into 1 squared. 4 can be converted into 2 squared. 9 can be 3 squared. 16, 4 squared. 25, 5 squared. 36 can be 6 squared. 49, 7 squared. And then we have 81 also as 9 squared. We have 100 also as 10 squared. So all these numbers are called square of numbers or perfect squares. Now we also have cube of numbers or perfect cube. We have 1 as 1 cube, 8 as 2 cube, 27 as 3 cube, 64 as 4 cube, and so on. You realize that those are called cube of numbers, so they are common sequence. We also have multiple of 2. For the multiples, we have multiple of 2. So multiple of numbers are also common sequence. So multiple of 2, we have 2, 4, 6, 8, 10, 12, 14, and so on. We can also talk about multiple of 3. We have 3, 6, 9, 12, 15, 18, 21, and 24, and so on. We have multiple of 4 also there as 4, 8, 12, 16, 20, 24, 28, 32, 36. Then we have the next type of sequence or common sequence. It can be the triangular numbers. Triangular numbers such as 1, 3, 6, 10, 15, 21, 28, 36, 45, and 55. We have prime numbers also as one of the common sequence. Prime numbers are numbers which are having only 2 factors. That is, only 2 numbers can multiply to get that number, or only 2 numbers can divide that number without a remainder. That means the prime numbers have factors like 1 and the number itself. So only 2 factors, 1 and the number itself. So something like 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and 31. Also going on, we can get so many of the prime numbers and so on. Another common or popular sequence can be the Fibonacci number. So that one is also called the addition of the first two numbers to get the next number. So if you look at the example in the 0, 1, 1, when you add 0 and 1, that is the first two terms, you should get the next third term, which is 1. When you add 1 and 1, you should get 2. When you add 1 and 2, which is the third and the fourth term, you should get the fifth term as 3. When you add the fourth and then the fifth term, you should get the sixth term as 5, and so on. So that means when you add any two numbers, you should get the next number to the two numbers. That is what we call the Fibonacci numbers. So these are some of the popular sequences that we have. The next thing that we can talk about is the pattern of sequence, how sequences are done in pattern. So let's take examples of pattern of sequence. We want to take a look at patterns of a sequence. Now, considering patterns of a sequence, we can talk about the fact that sequence is named according to the way its terms are arranged, right from the term or the first term. Now, when the first term of the sequence are listed, the sequence can then be described. Often, a particular formula can be used to get other terms from the same sequence. Now, other times also, the terms can be gotten without the formula. Now, by using the particular pattern in which the terms are arranged, we can get the sequence and its other terms. A perfect example will be the sequence 5, 10, 15, 20, and so on. Now, sometimes you need to give the next term in the sequence. Now, first look for the pattern you know, such as odd, square, cube, even, triangle, prime numbers, multiples, and etc. So you see, these are the common types of sequence that we have. So with that, we can then extract the pattern of the sequence by virtue of the arrangement. So if you look at such a sequence from 5 to 10, 10 to 15, and 15 to 20, we can then say that the sequence moves with a multiplication of what? 5. So the multiples of 5 are 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. So if you're asked to find the next three terms to this sequence, you can boldly say that 25, 30, 35 becomes the next three terms to the sequence. Based on this introduction, we can now solidify the argument that sequence, sometimes you don't need a particular formula to get the terms in the sequence. You can use just a normal pattern to get the terms in the sequence. So from the illustrative examples we are about to do in the subsequent videos, we are going to help you use a pattern in order to describe or get the terms in the sequence. So let us solve examples, or let's give you examples for questions that we need the pattern to be able to get the next term of the sequence. Now we want to take an illustrative example on this particular pattern of sequence. Now this question reads, find the next three terms in each of the following sequence. We have 1, 4, 9, 16, 25. We have 1, 8, 27, 64, and so on. We have 1, 9, 25, 49, and so on. We have 1, 2, 4, 8, 16. For we have 1, 4, 9, 16, 25. Now, checking for the next three terms, we need to get the pattern of this sequence. Now, we have to understand that here it cannot be a multiple of a certain number, and it cannot be an addition of a particular number. Still, it cannot be the subtraction of a particular number. Then it can also not be a multiplication or a division of a particular number. It means that this sequence does not depend on either arithmetic, that is adding or subtracting or multiplying or dividing. So it means that we have to take our time and know how this sequence was built or how this pattern was built. Now when we check well, we want to list down all real numbers called counting numbers. So let's list down all counting numbers. Now counting numbers starting from 1, we go to 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So with this, once we have the counting numbers now, we want to see if there is a relationship or there is a connection between the counting numbers and these numbers which are in the sequence. When we check, I want us to take our time and watch it well. Let us just square 1 and see the outcome. So 1 squared produces 1 as an answer. So it means that if I square the first counting number in the list, I will get the first number in the sequence. Now let me take the next counting number, which is 2. So 2 squared will produce or provide me with 4. So it means if I square the second counting number, I will get the second sequence. Let me see if that will continue till I get to the 25. So I'll take 3 squared. Then with the 3 squared, I get 9. It means that the third number in the counting numbers, when I square it or I give it the power of 2, I get a third number in the sequence. Which means that I can confidently say that this sequence was built from the square of counting numbers. So I'll continue to square them till I get the next 3 numbers in this sequence. So we go. We have the next counting number 4. We square it and we get 16, which is the next number on the sequence list. Then we continue. The next counting number is 5. 5 squared, we get 25. So we need 3 of them. That means that 3 terms after 25 will be the counting number 6 squared, the counting number 7 squared, and the counting number 8 squared. But 6 squared gives us 36. So the next number after 25 will be 36. Then the next one, 7 squared, will give us 49. The next will be 49. And then the next 8 squared will give us 64. We get 64. So the next 3 terms for the question I will be 36, 49, and 64. So we can conclude that this sequence was built out of the square of counting numbers starting from 1. So please take note. And this is what we call a pattern of a sequence. Let's take the next one. The sequence is 1, 8, 27, and 64. Now with this, we have to take our time. We have to analyze them from all the operational signs. Now, no number will be added throughout to get a sequence. And no number can be subtracted throughout to get a sequence. Either ways, the multiplication and division sign can also not provide a sequence with this. So it means that there is a particular pattern that has nothing to do with addition, subtraction, multiplication, or division. So it means we have to take our time and get a sequence. We have 1, 8, 27, 64. We check well. Let's put down all counting numbers and see whether we can get a relation between them. The counting numbers starting from 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Now, we want the next 3 terms after 64. So when you check the counting numbers, now even though here in the first question we saw the square. So let me square. 1 squared is 1. But 2 squared is not 8. So that means it will not be the square of the counting numbers as we saw in the previous video. But with this, we can boldly say that let's jump from square to cube and see whether the pattern will be achieved. So then when we have 1 cube, we should get 1. So meaning that the cube of the first counting number resulted or gave us the first term in the sequence. Then let's go to number 2. So 2 cube will give us 8. It means that we are getting the sequence for number 210 or the second term in the sequence after we cubed or we gave a power 3 to the second counting number, which is 2. So 2 cubed gave us 8. It means the pattern goes with cubing or raising the counting numbers to a power of 3. So 3 as the third counting number raised to the power of 3 gives us 27. And that is the third term in the sequence. So we go to the next one, which is 4 raised to the power 3, giving us 64. And that becomes the fourth term. So to get the next 3 terms, that means we have to choose the next 3 numbers in the counting numbers, which is 5. We cube it to get an answer. 6, we cube it, and then 7 also cube to produce the terms that will be the next 3 terms in the sequence. So 5 cube will give us 125. So the next term will be 125. Then 6 cube will give us 216. Then 7 cube will also give us 343. So it means the next 3 terms in the sequence is going to be 125, 216, and 343. So this one will be the next 3 terms in the sequence for the question So that becomes our answer. Please take your time and go through it very well. Normally, don't necessarily think we are giving the powers to get all the sequence. It is just a simple trick. You need to go through a lot of patterns to get to know the right one that goes for the sequence. Now, looking at the question number III, that is the third one on this sequence, we realize that the sequence in the III is 1, 9, 25, and then 49, and so on. Now, checking from here, the addition of a number or the addition of a constant number cannot bring out all these terms in the sequence. Also, the subtraction of a constant number cannot bring out the terms in the sequence. Multiplication, division, both cannot bring out the sequence or the terms in this sequence. So we just have to stick to the square or the cube. But looking at this, all these are perfect squares. But they are not perfect squares of the counting numbers. They are perfect squares of the specific counting numbers. So checking from here, I can talk about 1, I can talk about 3, I can talk about 5, I can talk about 7. Okay, so 1, 3, 5, 7 becomes odd numbers. So 9, 11, 13, and so on can bring out the third or the next three terms of the sequence. So it means this sequence is squaring numbers in the counting numbers called odd numbers. Squaring odd numbers starting from 1. That is how we created the sequence. So it means 1 squared gives us 1, and it is true. It becomes the first term in the sequence. So the next number to the odd numbers is 3. And 3 squared gives us 9. And 9 becomes the second term to the sequence. Then we have 5. So 5 squared gives us 25. It becomes the third term to the sequence. Then we have 7. 7 squared gives us 49. Becomes the fourth term. So it means clearly that we are certain about the fact that the sequence is made up of squaring odd numbers. So let's check for the next three terms. If 7 ended this sequence and then the next three are unknown, then we can start from 9 squared, we can talk about 11 squared, and we can even talk about 13 squared. 9 squared will give us 81. So the next term after 49 in the sequence will be 81. Then 11 squared will give us 121. So the next term after 81 will give us 121. And then 13 squared will give us 169. So the next term will be 169. So the three terms or the next three terms in this sequence will be 81, 121, and 169 respectively. So that is how it will become. So therefore this sequence in conclusion will be a sequence which has the square of all odd numbers starting from 1. So the sequence is made up of squaring odd numbers which start from 1. Thank you. Now in this particular sequence at IV, we have 1, 2, 4, 8, 16, and so on. You realize that this sequence, that one, we can suggest the operational signs for the movement of the terms in the sequence. Let's go straight to the point. Now we have 1 times 2 will give us 2. 2 times the same 2 will give us 4. 4 times 2 will give us 8. 8 times 2 will give us 16, and so on. So it means that this sequence is a multiplication of the number 2. So multiple of 2. So that means we use 2 as a constant to multiply the terms to get the next term. So 1 times 2 give us 2. And 2 times 2 give us 4. 4 times 2 give us 8. 8 times 2 give us 16. So the next three terms will be 16 times 2 will give us 32. So 16 times 2 gives us 32. Then the next one will be 64. That is 32 times 2 will give us 64. Then we get 64 times 2 will also give us 128. So the next to that will be 128. 128. That means the next three terms to this sequence 1, 2, 4, 8, 16 will be 32, 64, and 128. So we can conclude that this sequence is a sequence which produces its terms by the multiplication of the constant 2. So you multiply 2 by any of the terms to get the next term. So it is a multiplication of 2 to get the sequence. So remember that the pattern of a sequence actually depends on the nature of the movement of the sequence. The terms, one after the other, how they form themselves with the previous term, shows you how the sequence is moving. So please take note. You are not always going to get the sequence by addition, subtraction, multiplication, or division. Sometimes you need to really think about squaring, cubing, or even adding the first two terms, and so on. So that is what we call pattern of a sequence. Now, ladies and gentlemen, let's then go deep and look at what we call arithmetic progression and then the geometric progression. That is for the type of sequence.